Pluto, likewise, compels us to re-evaluate the role that frigid worlds play in our search for life. Previously, astrobiological research has focused on planets and moons closer to the Sun, where liquid water can exist on the surface. However, with each new mission, it becomes increasingly evident that life, if it exists elsewhere in the solar system, might thrive in environments we once believed were too harsh or too remote. Europa, one of Jupiter's moons, has been an excellent candidate for such studies, and now Pluto might join the ranks of these intriguing, potentially life-bearing worlds. As exciting as these discoveries are, they also highlight the limitations of our current technology. While the data gathered by New Horizons and JWST is groundbreaking, much of the information about Pluto and other distant objects remains incomplete. To gain a fuller understanding, future missions must go even farther, probe even deeper, and collect more detailed data. This means that investment in space exploration must continue to grow, ensuring we have the necessary tools to answer the questions raised by missions like New Horizons and JWST. One of the most challenging aspects of space exploration, especially when it comes to distant objects like Pluto, is resource allocation. Why invest millions or billions of dollars in studying a small icy world at the edge of the solar system when there are more immediate concerns, such as finding planets that might harbor life closer to home? This is a question that space agencies like NASA must grapple with as they plan future missions. However, as the New Horizons mission has demonstrated, exploring these distant worlds can yield unexpected and invaluable discoveries. The data gathered from Pluto may ultimately inform our understanding of the entire Kuiper Belt, a region that remains one of the least understood areas of the solar system. The search for life beyond Earth has long been a driving force behind NASA's missions. With the discovery of phosphorus in Enceladus Ocean, the possibility of extraterrestrial life has become even more plausible. Phosphorus, a key building block of DNA and RNA, is essential for life as we know it. While there is still no definitive evidence that Pluto's ocean could support life, the presence of water opens the door for further exploration. As we continue to probe the outer reaches of our solar system, missions like New Horizons and JWST are reshaping our understanding of distant worlds. The data collected so far has already forced scientists to reconsider long-held beliefs about Pluto and the other small bodies that inhabit the Kuiper Belt. While the debate over Pluto's planetary status may continue, one thing is certain: the dwarf planet is far more active and complex than we ever imagined, and its story is far from over. Pluto continues to surprise us in ways we never expected. While NASA is not actively probing ice-encrusted planets at the moment, Pluto is delivering remarkable discoveries that challenge our understanding of distant planets. One of the most astonishing findings is Pluto's unique form of volcanic activity. Let's break this down. Pluto, a planet that was demoted in status, not only has a heart-shaped region that reorients its spin axis and possibly an ocean beneath its crust, but is also volcanically active. This has led a large group of scientists to fiercely criticize the International Astronomical Union for stripping Pluto of its planetary status, but that is a debate for another day. Right now, let's focus on the volcanic activity of this icy world. When we think of volcanoes, we typically picture scorching magma erupting from a mountain like the lava flows from Hawaiian volcanoes, which can reach temperatures as high as 1,250 degrees Celsius (2,200 degrees Fahrenheit). But Pluto's volcanoes couldn't be more different. Thanks to NASA's high-resolution imagery, we've learned that Pluto has its own unique type of volcanic activity called cryovolcanism. Instead of molten rock, frigid, slushy ice erupts from the planet's surface. This cryomagma, near freezing in temperature, pours across the surface before solidifying, creating new and unusual geological features. Pluto's iconic heart-shaped region, known as Sputnik Planitia, also plays a central role in this volcanic mystery. In the southern part of this region lie two towering mountains, Wright Mons and Picard Mons, which scientists now believe are the mouths of cryovolcanoes. But that's not all. NASA's research has also revealed evidence of ice volcanoes in Pluto's western region, Viking Terra. This area shows deep cracks and ridges that may have formed due to the movement of supercold magma. These discoveries have led to significant changes in our understanding of the dwarf planet's geological activity. Pluto's largest moon, Charon, has also been the subject of incredible discoveries. Once considered less significant than moons like Saturn's Enceladus or Uranus' Miranda, Charon has now emerged as a key object of interest. The moon's surface features two radically different terrains: Vulcan Planum, a smooth plain in the south, and Oz Terra, a rugged terrain in the north. These contrasting landscapes suggest that Charon, too, might have an ocean beneath its icy crust, offering yet another target for future exploration. But it doesn't stop there. NASA's high-resolution imagery has revealed something unexpected. Pluto has dunes. Yes, you read that right, dunes. Unlike Earth's sand dunes, Pluto's are composed of methane-infused ice grains that have been eroded from the Sputnik Glacier. Despite the planet's weak gravity, thin atmosphere, and frozen surface, these dunes are scattered across its icy plains. As we stand on the brink of new discoveries with the James Webb Space Telescope, it's clear that Pluto's status as an inactive world is a thing of the past. The data we have gathered, just a few gigabytes, has unlocked vast possibilities, giving us a clearer picture of this fascinating distant world. As we venture further into the mysteries of our solar system, the role of smaller icy bodies like Pluto and its moons becomes increasingly significant. These worlds, often overlooked in the past, are now at the forefront of planetary science. The discovery of geological processes such as cryovolcanism on Pluto is reshaping our understanding of what makes an environment habitable, not just in terms of the presence of water but also in the types of energy sources that could exist in such distant locations. The fact that ice volcanism occurs on Pluto suggests a level of internal heat, potentially from tidal forces exerted by its moons or radioactive decay within its core. This opens new avenues for exploring how planets and moons far from the Sun could sustain complex processes similar to those on Earth. Moreover, Pluto's dynamic geology challenges long-held assumptions about the longevity of planetary bodies in the outer reaches of the solar system. The relatively young, active surface of Pluto, combined with the possibility of an ocean beneath its icy crust, indicates that these distant worlds may be far more dynamic than previously thought. In 2013, Pioneer 1 achieved an amazing accomplishment by becoming the first human-made object to enter interstellar space. This exceptional achievement happened 36 years after its departure from Earth. The space probe now resides 14.5 billion miles from Earth, requiring around 2 days for the transmission and reception of messages. NASA engineers never anticipated that Pioneer 1 would continue its space exploration for nearly 50 years. In 2013, Voyager 1 detected 500 unidentified objects traveling through space, sparking enormous debate. Notably, famous podcaster Joe Rogan joined the discussion to shed light on the complex implications of this extraordinary discovery. These mysterious objects might have been created by extraterrestrial beings or could simply have been a glitch in the spacecraft's instruments. The mystery has fascinated experts for a long time. However, recent unusual encounters in deep space have sent shockwaves through the scientific community, possibly providing insights into the age-old question of extraterrestrial existence. Joe Rogan, a well-known journalist and podcaster recognized for his deep interest in exploring extraterrestrials and advanced civilizations, has previously hosted guests like David Grush and Avi Loeb to discuss the possibility of life beyond Earth. The Voyager mission. The Voyager 1 mission was conceived in the 1970s, when NASA scientists had the opportunity to better understand the vastness of our universe. It all began with a rare planetary alignment of Jupiter, Saturn, Uranus, and Neptune, the 4 largest planets in our solar system. A young PhD student named Gary Flandreau discovered a remarkable celestial phenomenon that would guide space exploration in the late 1970s and early 1980s. The 4 planets aligned in a breathtaking configuration, resembling pearls on an extraordinary necklace, with Earth nestled among them. This discovery thrilled NASA, as it presented a unique opportunity to optimize the trajectory of a spacecraft by cleverly utilizing the gravitational pull of each planet during flybys. Flandreau estimated that these gravity assists from the giant planets could reduce the travel time from Earth to Neptune from 30 years to just 12 years. However, this rare planetary alignment occurred only once every 176 years, prompting NASA to embark on an ambitious mission to capitalize on this once-in-a-lifetime opportunity. The launch of Voyager 1 and 2. Voyager 1 and Voyager 2 were twin spacecraft launched in 1977 to explore the mysteries of the solar system. Launched 15 days apart, they became crucial parts of NASA's Voyager space program, a testament to humankind's insatiable curiosity and quest for knowledge. For nearly 50 years, Voyager 1 has been transmitting valuable data back to Earth through NASA's Deep Space Network, bridging the gap between our home planet and the secrets of the cosmos. As of now, Voyager 1 is 24 billion kilometers away from Earth, making it the farthest man-made object from our planet. The spacecraft was meticulously designed and built by NASA's Jet Propulsion Laboratory, JPL, and began its historic journey from Launch Complex 41 at Cape Canaveral Air Force Station, propelled by a Titan IIIe launch vehicle. Advanced systems and longevity. A crucial feature of Voyager 1's launch was the inclusion of dual redundant computer systems. Both Voyager 1 and Voyager 2 were equipped with two sets of command and data subsystems, CCS, flight data subsystems, FDS, attitude and articulation control subsystems, AACS. This redundancy ensured seamless transitions between systems and the ability to activate dormant computers when necessary, significantly extending the spacecraft's lifespan. The onboard computer systems were organized as a distributed system, with 3 redundant sets of computers ensuring that if one system failed, the others could take over smoothly, preventing critical malfunctions. Power management challenges. Power management has been a crucial factor in maintaining Voyager 1's operational integrity, especially as its increasing distance from the Sun makes solar power collection impossible. Engineers had to devise innovative strategies to monitor and optimize power consumption, including selectively shutting down non-essential systems. A legacy of discovery. In summary, Voyager 1 and Voyager 2 have been instrumental in uncovering the secrets of the solar system and interstellar space, providing invaluable insights into the vastness of the cosmos and the mysteries beyond human understanding. Voyager 1 is a spacecraft that has defied all expectations, continuing to transmit crucial data nearly 50 years after its launch. Initially expected to last only 5 years, it was equipped with a vast array of scientific instruments and subsystems. These instruments were strategically placed on the spacecraft's body, which contains an astonishing 65,000 individual components. One of the enduring instruments on both Voyager 1 and Voyager 2 is the low-energy charged particle detector. This instrument consists of 3 pairs of particle sensors that measure the number of low-energy particles striking it, as well as their speed. It continuously monitors high-energy radiation and particles originating from the Sun, planets, and interstellar space. A companion instrument, the cosmic ray detector, actively searches for high-energy particles from both the Sun and other celestial sources. The plasma wave subsystem, which includes 2 extended radio antennas arranged at right angles, serves as a critical tool for measuring the electric field components of potential waves encountered near outer planets. However, its role has evolved as the Voyagers have ventured into interstellar space. Continued advancements. Over the years, engineers have developed remarkable technical advancements, including more efficient power distribution, improved battery charging methods, advancements in power regulation and control. A timeless mission. Voyager 1 continues to transmit fundamental data, demonstrating the dedication and ingenuity of the engineers and scientists who have worked on this mission. It stands as a testament to human curiosity, scientific advancement, and the unrelenting pursuit of knowledge beyond the boundaries of our planet.